Francisca, may I open your PDF? May I open to test? Oh no. To share the session here, I only share the window or
I think the entire screen is fake.
entire screen, but when I share entire screen,
Can I use your?
yes,
Do you have virtual or?
the first is in presence. All the others, I think, in this session, five, five, here. The first is in presence. Francesca is already here, and the others are online virtual.
Okay, they will share themselves, but for this one, we can get the presentation already with the USB. Francesca, here is the presenter.
The presenter here is here, and the presentation is here. This text.
Ah, okay. So when we do this, I think they see.
Okay, they see.
We can. Hello.
Hello, Gustavo. Gustavo Sotinho.
Yes. Hello.
Can you see if you can you tell me if you see
Yes, I can see the presentation.
the presentation of Francesca? Yes.
I need to send the my PDF or not?
No.
No, you will
it's not
share
necessary.
directly. No, for now they didn't ask that.
Okay. We are on time. It's early.
Yes.
We
it's
start 2 o'clock, if you don't mind. Okay, thank you. Your name is
Bilge. Bilge.
Bilge. Bilge. Vais-me levar a escola? Não sei. Pergunta se ele tem asas. Está bem, está bem. Olha, mas não se esqueça, sabe que já tem que estar aqui. Mas nós estamos só aqui à volta, mesmo. Ok. E vamos andar de transporte. Mas olha, eu que não quero. Está bem, o Reis. Está bem. Já agora, acho que o barco, né? Hã? Acho que o barco. Antes, acho que é antes. Hã? Eu acho que eles disseram que vem a outra hora, mas eu tenho que estar com tudo. Gustavo, only one question.
Yes.
Which paper will you present?
The last one is the name.
The second or the last?
The last one.
The last one?
Imputation of response
Imputation of
variable.
response
Yes.
variable. The other
Yes.
is Luis, right?
Yes.
Okay, thank you.
Nah.
I need Rino. Okay. Gustavo, Gustavo,
Yes, yes.
sorry. Can you ask if Luis could be present?
I think so because I talked with him this morning, so probably it's
It's
entering the
more
same minutes.
easy in Portugal to phone to Luis.
Yes, I
Okay,
can call him. Okay, thanks.
okay. I will start on time.
Olá, professor. Vai entrar um bocadinho mais tarde ou agora? Ok, ok. Até já, então, até já, até já.
So we think I wish I think only your is fine. Maybe center of the not the last, the fourth, the fourth, the third. Yes, the third. Okay. Can you contact me? Try. Try. We will start. Uh, uh, Welcome to one more section of Professional Applied Statistics. My name is Anna, and I'm here to share and in this session. And we have five presentations in this context. We start by conversation in presence with the paper entitled Dedicated Student Education and Economic Degree Program. And you can start. Gustav, please
Yes.
turn off your microphone and your
Okay.
sound. Okay. And you have your papers here and sharing with you. If you want, you can go to this. To don't see the here. Yes. Okay. Thank you. So if you want, I said you can. If you want to be online, you are here to present. If you don't want, you can.
Okay, I can't say that.
This one it's only for the projector.
Oh,
You
I
need
see.
to.
So I need the mouse. Okay.
I don't know if the mouse works.
No.
In the morning don't work. If you want to enter this what? In the morning I try.
In another class, to move from one slide
Wait.
to another.
This is from the mouse. We don't have the pointer here because we don't know.
So to move from one to another.
But
You can move with the mouse with
you
this
know why? There's only one connection here, and that's the mouse. This needs to have another one.
another one, but we don't have.
No, right.
So, just in this way. I move just in this way.
This is
Yes.
not here.
They dropped it.
There's one on this computer too. Don't worry, we
Sorry.
try. This is only presence. When you are ready, Francisco,
Okay.
you can start.
I think we are going to put on this side because I don't want to give it back to,
Yes.
to the audience. Okay? Okay. Okay. Good afternoon. I'm Francesca Pierri, and this is a joint paper with Chris Camoni from the Department of Mathematics, National Technical University of Athens. This is the outline of my presentation. It is divided in 4 groups, and I will start with a brief introduction, and then I will give you something about the methodology applied. You will find more deeply in the paper. Then I will describe you the application with the description on data and the results, and then I will give you some comments. Then I'm waiting for your questions if there are. So the university, universities during the last years, last decade, try to increase the number of students enrolled annually, and contemporary in the same time, they try to reduce the extent of the phenomenon of dropouts and try to improve and accelerate academic study pathways, because in Italy, the funds that we received from the Ministry of the University are based on the number of students regularly enrolled with a period of stay with a bachelor degree no longer than 4 years. And there is an economic effect on the families, on the household spending, because the annual enrollment fee paid by students rises, and the regional subsidies like the canteen access or grants decreases. So the aim of the paper was to identify the strongest predictors of the dropping out risk, And we focused attention on students' characteristics, educational background, and educational performance. We applied two main models: the logistic model that modeled the probability of a binary or multinomial outcome based on one or more predictor variables. And then we applied the survival analysis because we were interested on time, the time of the event. In a binary logistic regression model, we have a Bernoulli random variable and a set of and a covariant vector, and we are interested in the odds ratio, that is the E beta power. It expresses the change in the odds of the outcome occurring for a 1 unit increase in the value of the predictor variable. When we have more than two events, so a positive, we may have a positive and negative event. In the dropout, event, it will be the zero event, and the success event will be the one event. When we have more than one cause of dropout, we can use the multinomial logistic regression. The dependent variable is a nominal dependent variable, and so we will use one variable as the reference during the interpretation of the data. In survival analysis, we are interested in time. So we introduce the variable t. It expresses the random time until the event, and beta is the vector of the coefficients denoting the fx of a vector or covariance x upon t. So we have, in survival analysis, we expresses the probability that a subject will survive until at least time t. So in simple survival analysis, we may describe an event through the Clapeyron curve, or we can model data using the hazard ratio function. And and in the semi-parametric proportional hazard model, the Cox model, we have that the covariates act multiplicatively on an unspecified baseline hazard H0 through the factor e power to beta. And so we are interested on the value of e power to beta. When we have more than one event, we use a competing risk model. There are two types of competing risk model: the subdistributional hazard model or fine and gray model, or the co-specific model. We have used the subdistributional hazard model, and this is the formula, and it expresses the instantaneous rate of failure at time t among subjects that have not yet experienced an event of type k. So all the other are competing. Okay. Sorry. Oh. I've used a software. I've used SAS on demand for academics. It is a free software for academics. It is a stable software, and in this occasion I've used SAS because I have Proc Logistic, that is a binary that performs binary and multinomial logistic regression. Proc PHREC that performs Cox and fine gray model. And then I used HP split. It is a decision tree model, and it was useful to explore data and for classification purposes. And so I'll show you some graphs, some interesting graphs. Okay, something about the data. We have a cohort of students enrolled at the University of Perugia, and they are followed from the first registration in 2015 until January 2025. We have 3 different bachelor's degrees, 2 in business administration and 1 in business for tourism. The students' information we have is the anonymous numerical identification code, and information about the gender, region and district of residence, type of secondary school attended, diploma obtained and the related mark, and the student's current status with the dates of change of status. It is important for survival analysis. Then we have classified the students' status in the following way. Graduated students have the status number 1. Then we have in status 2, we have the students that officially dropped out from studies. In status 3, we have the deleted records. So these are the students that were inside the university database for 8 years. I remember you that the bachelor degrees is of 3 years. It is 3 years or long. And during these 8 years, they have not taken exams. During the last years, they have not taken exams. Then we have a status number, status equal 0, and these are our censored data on in survival analysis, in competing risk analysis. And these are the students that are still enrolled at the university. And during the last year, they may have tried to give an exam, even though they didn't succeed. So they are still inside the university. This is the distribution of students by degree, course, and gender. There isn't a difference among female and male on the basis of degree of the degree course, and can move with the. And this is the distribution of type of school attended by gender, and we see that the students attending the economic courses principally obtain a scientific and technical diploma. Female obtained also a classic diploma. I'd like to show just one now. Okay, this is the distribution by status, and you see why the aim of my department was to know more, to deep on the problem of dropping out, because we have only the 54.6% of the students finished their studies. These are the results. This is the covariance effect on the probability of success in the binary model, and these are the significant covariates. And among all the covariates we considered, the only significant were the school graduation mark. It has a positive aspect. The meaning is that higher is the diploma graduation mark, higher is the probability of success. And for a student, the probability of success decreases if he has attended a professional or technical or mixed school. This is a decision tree. I don't know if you can see probably. May I enlarge this slide? Is it possible? You think? Anyway, there is the new status equal 1 are the graduate students, and I've included in this the time. I've included the time. I have seen a first branch at less than two, a little bit more at 2 years, point 12. That is, it is not the time of to finish the university. So I went to explore these students, what happened to these students. Really, these students changed the course. So I decided to apply a multinomial logistic regression, and considering also the status 2 and the status 3, and from multinomial logistic regression, we obtained that the degree course was important, because the probability to be in status 0, that is to be to be still inside the university after 8 years is more probably if you are attending a L025 course. That is a course, a smaller course in a smaller province of Perugia, and the probability to be in status 2 and status 3 increases if you have attended a professional or technical high school. In this graph is more clear as the classic school and the scientific school attended increases the probability of success. In the classic survival analysis gives the same results, quite the same results than the binary logistic regression model, but there is an important thing, because the school graduation, the importance of the school graduation time, the importance of the school graduation mark decreases with time. So the effect of time is less than 1. It decreases with the time. And performing a competing risk model, we see that we obtain different importance in different ways. For instance, for status 1 is important, that is the graduated student, is important the school attended and the school graduation mark, and it's not important, the effect of time is not important, is not significant. For status 2, it is the probability to change the course after by 2 years. We have that female are less prone to change the course, and the importance of the school graduation mark decreases with time. In status 3, for status 3, that is the students that were deleted from the database, we have that students in L025, the probability to be in status 3 for students in L025 decreases, and decreases the importance of the graduation mark, but increases by the time. So we obtain the importance of the same coverage, but with a different effects in the different status. So the results show you that the secondary school attended and graduation mark are important. The competing risk analysis highlights how the time influences some predictors effects in different directions for different course of exit, suggests that females are less prone to change course compared to males, and as future directions, we are increasing the quality and quantity of data used. We are attending the data from the university. We are attending data on annual students' credits and more cohorts of students enrolled after 2015. I thank you for your attention. Is there a question? Thank you.
Thank you for your presentation. I ask for the audience some questions and 1 minute of questions. So I want to congratulate you for your work, and I have only one question. You tell a plot before 2015.
Sorry, you?
Your work, your time is from each year to which year?
Yeah.
Which the time you study?
We consider the 10 years. 10 years from 2015, the first enrollment, to 2025, just today. So 10 years.
10 years.
And so if you want, I can show you the. I didn't want to go longer. These are the campaign parts, for example,
Yes.
for the types, for the type of codes. So we have 10 years.
10 years.
10 years.
I don't think it's the same.
Yeah. Because I consider 10 years because the aim is to follow the students under the bachelor degree, just to see how many of those are attending the master degree, or are they going abroad? Because we have a big number of students attending the bachelor degree, and then few numbers for the master program. So the number is 500 students or 600 in Perugia, just in Perugia, in a course for the bachelor degree, and then we have 60, 70 students for the master degree. They often go abroad or in Milan or in another big cities. So we would like to study this phenomenon.
Maybe the students in
Yeah.
your
Yeah.
city
Yeah.
is better. Thank
Okay,
you. One
you're
more.
welcome.
And now we proceed in virtual sessions. Wait a moment. So I only ask if all presenters are here. Wish it's here,
Yes.
right? Mario, Angeli, I see
I'm
you
here.
guys.
Hello. Can you hear me? Angelelli?
Yes.
Yes. Okay. Thank you.
And Flora, it's too, Flora Ferreira. Yes. And Gustavo is all in. So I ask for the first virtual presentation for Luis Machado to present his work. Everyone could see.
Yes.
So when you are ready, Luis, you can start.
Okay. So I guess you all can see my presentation.
Yes.
Yeah.
Here
So,
in the room, we saw that. I think in the Virtual
Sorry?
room, I think, is okay too.
Okay.
You can proceed.
Yeah, thank you.
You can proceed.
Yes? Okay, I will proceed. So, good afternoon. This is joint work with Marta Azevedo and Gustavo Soutinho about an R package that we call Survival TB, and which was developed for survival analysis with interval sensory data. So before I begin, I would like to thank Anna for organizing this nice workshop within the ICCSA conference. Unfortunately, due to medical reasons, I am not unable to attend in person. Well, but even so, I'm glad to be able to participate remotely. Survival analysis, and again, this talk, as the previous one, is on the scope of the survival analysis. This area studies the time to a particular event of interest. While it is originally in clinical contexts, like time to death, it's not now. It's now widely used in many other fields, and as you can see here, some examples. Well, survival analysis is characterized by the presence of incomplete data, typically due to censoring, and this censoring occurs when the exact time of the event of interest is not fully observed. It is commonly classified in three groups, as shown here: right censoring, left censoring, and interval censoring. So in this presentation, we will focus on the interval censoring, a situation where the event is known to have occurred within a specific time interval. However, the exact time is still unknown. And it is represented here, in this case, by this figure. So interval censoring is common in studies where the events are only observed at scheduled visits. In these cases, the exact time is unknown, but is known to lie within an interval. Therefore, we need the information about two variables. Usually, they are named as left and right variables. So due to the lack of software for these kind of methods, researchers often resort to imputation methods, such as using the midpoint, probably the most used approach, but also the left endpoint or the right endpoint of the interval. However, these approaches ignore the uncertainty that can, in the data, that can lead to biased results and also to misleading conclusions. The data structure, as shown in this small amount of data, is based on the observation of two intervals, two variables which define an interval, left and right. And note that the right censoring is a special case where the right variable is infinite or unknown, and left censoring is also a particular case in which the initial time, the left time, is set to 0. So this indeed makes important the case of interval censoring, since it can be seen as a generalization all of the types of censoring. So these slides illustrates a common but a naive approach to deal with this problem, which is midpoint imputation, which it is based on the midpoint of the interval just computing the L plus R divided by 2. And we have also the corresponding status. So in this case, we are assuming that we have an exact event at the midpoint of the interval. But even so, in these cases, we may observe also right censoring. And so in this case, we only have right censoring under the midpoint approach, and we can use a lot of methods that are all already available for right censoring. One important goal in survival analysis is the estimation of the survival function, which gives the probability that the event has not occurred by time t. Traditionally, and for right censored data, this function is estimated using the well-known Kaplan-Meier estimator. Well, it is a non-parametric stepwise estimator that works pretty well if we know the exact event times. However, the Kaplan-Meier estimator cannot be applied to interval sensory data since it relies on this, that we have exact event times. And so it can lead to bias and misleading interpretations. Okay, so proper methods such as the Turnbull estimator are required to deal with this kind of data, interval sensory data. To introduce the Turnbull estimator, we need to introduce the so-called Turnbull intervals, which are introduced in this slide. So given a set of the left and right endpoints for the observed intervals, which are obtained from the variables left and right, we can construct the Turnbull intervals, which in this case we denote Uj and Vj, such as that Uj must be a left interval, Vj must be a right interval, and there is no left or right interval between the two of them. So in this small example of data, we have just five observations, and from their endpoints that we can see the right and left endpoints, we can identify, following this rule, the Turnbull intervals. So in this case, we have only 3 Turnbull intervals. Well, here we apply the package that we have developed for dealing with interval sensory data. Well, in this example, we have 5 observations, each defined by an interval, which is defined by the 2 variables left and right. And using the function that we have developed, the TNB intervals, we get a table with the Turnbull intervals, and also in the same output we get the associated probability mass in each interval, which is called the weight in this case. And the survival columns shows the value of the survival function, which we get from the Turnbull estimator at the end of each step. Okay, so this slide outlines the steps of the Turnbull estimator, which is essentially an EM algorithm adapted for interval sensory data. So in step 1, we have to define the Turnbull intervals, as I explained it later. In step 2, we have the initialization. We start by assigning equal probability to each interval. Then we enter the iterative part, the E step and then the M step. In the E step, we compute the expected number of events in each interval, given obviously the current probability. And in the M step, we update those probabilities based on these expectations. Finally, we estimated the survival function by subtracting the cumulative probability mass from 1. So this will result in a stepwise survival curve, which is very similar to the Kaplan-Meier curve, okay? So while the package like survival, interval, and ICCSA offer some support for interval censoring. Well, they often lack direct access to Turnbull intervals, for example, or they present some limitations in terms of plotting and bootstrapping. And so the survival TB, our packages, addresses these gaps. Okay, so it computes the Turnbull intervals, estimates survival from the Turnbull estimator, provides the confidence bands, and supports also both static and iterative plots. Well, our long-term goal is to use the Turnbull intervals and weights that can be obtained in our package, well, in multi-state analysis. So you can see here some equations that were obtained to estimate the transition probabilities in multi-state models. That is an important area of our research. But in this case, we are dealing with right censoring only, and we want to extend these estimators to interval censoring. And we want to use the Turnbull intervals and the weights associated to those intervals. So these are the core functions of the package: TNB intervals, TNB survival, and two-plot functions, since one of them will provide interactive visualizations. To illustrate the package, I'm going to use a real data set from a breast cancer, which studies time to cosmetic deterioration. It includes both interval and right sensory data, as you can see in this small sample of data also. So from the TNB intervals, the function that provides, allow us to get the Turnbull intervals, we can get the Turnbull intervals, but also the weights, the estimated weights, meaning the probability mass associated to the corresponding weight, and the cumulative survival at each step. Okay. It is very simple within our package to get the estimated survival along the 95% confidence intervals for the selected time points. For example, in this case, for time points 5, 10, 15, 20, 13, and 14. And we can use the two functions that we have developed in our package. It supports both static and iterative plots. The iterative option is based on Plotly, the package Plotly. And I think it is very useful for exploratory analysis and or communication of results. Okay, so to summarize, interval censoring are very common, but still under-supported. The Turnbull estimator to estimate survival function is the appropriate approach, but is not user-friendly, as the Kaplan-Meier estimator, for example. Our package, the Survival TB package, offers a comprehensive and open solution. It is available on GitHub with the documentation and the examples. There is an ongoing work which includes many topics on this area, on the interval censoring area. So, for example, comparing multiple survival curves, it is a very interesting topic and very easy to do. The clustering of survival curves, and I have been working on the building clusters of survival curves for right sensory data, but I want to extend this to interval censoring also. And also using the Turnbull weights and the Turnbull intervals to extend the estimation methods that we have developed for multi-state models, for example, to estimate the transition probabilities, the estimator of the bivariate distribution function, and so on. So there are some packages that are already available on CRAN. I think I'm going to skip this slide, but you can find them on R. Some of them are very interesting, and they include up-to-date releases. And well, that's all. Thank you very much for your attention.
Thank you, Luis, for your presentation and for the timing. Someone have some questions in the room? No. In the virtual room? No. I want to thanks to Luis to his presentation, and I only want to ask you, these packages are available in GitHub, but you don't publish yet in CRAN, or you have?
Yeah. That's a good question. We haven't done it yet because we want to improve the package. We want to include many other things. For example, one important thing is to estimate the survival function conditional on covariates. It is very easy to do for qualitative covariates, but for continuous covariates, it is not that simple. Okay, that's one thing that we wanted to do for this moment. And there are many other topics that I want to improve in the package before submitting to R. But yes, we aim to do it.
It's the first version of one great version,
Yeah.
I hope so. Thank you, Luis, once again. And we prepare for the second virtual speaker. I think, no, yes, sorry, I'm the next section. Mario, are you there?
Yes, I'm here. Hi.
Hi, can you share your presentation with us?
Absolutely,
And
yeah.
when you are ready, you tell me to start.
Absolutely. I'm sharing. Can you see the screen?
Yes.
Okay, perfect. Oh, sorry. Please tell me when I can start and.
You can start now if you are ready.
Okay, perfect. Thank you. First of all, I'd like to thank all of you also for the nice presentations I'm seeing. I'm Mario Angelelli from the University of Salento. This is a joint work with Pedro Macedo, Jorge Cabral, Vera Freiso from the University of Aveiro, and Francisco Macedo from the University of Coimbra. This work deals with the combination of two statistical approaches and methods for estimation and for inference, namely ridge regression and generalized maximum entropy. I'm going to present first the issues and the problems in estimation, especially from coming from multicollinearity, from collinearity, which motivated this research. I'm going to briefly recall the main aspects of both these two methods for estimation and the issues we address for both of them, the proposed estimator, and the procedure we implemented in the package, also in considering our R or MATLAB implementation, and the first empirical application to explore the different approaches and the advantages and limitations of our proposal. As I said, what the main motivation guiding our research is the fact, the well-known fact that hill conditioning, or generally hill-posed problems, often arise in the analysis of statistical data sets. They could arise from multicollinearity, from collinearity or multicollinearity, namely the occurrence of even approximate linear relationships between different variables, different predictors or explanatory variables, which prohibits the use of, for example, standard approaches, standard just like ordinary least square, for example, due to the lack of the impossibility to invert the given matrix, the gram matrix used for constructing OLS estimators. There are clearly some other approaches based on pseudo inverses, but in any case, the issue of multicollinearity or the presence of more variables than observations, which is often which arise, for example, in biogenetics, in the study of omics sciences. Even when we address for other extended approaches for estimation, they could lead to unstable estimates, as also discussed through the conditioning number of specific matrices. So there is the need to cope with and to deal with this issue with ill-conditioned or ill-posed problems. One of the main approaches, the widely used approaches, is to rely on ridge regression, which include the form, in some sense, the ordinary least square objective function by including a penalty term on the sides of the coefficients. The ridge regression is based on the LQ norm of the coefficients, so the squared norm, which is controlled by the ridge parameter, returning the ordinary least square estimator when the lambda is equal to 0. This approach is well known and is useful as it does not remove any variable but shrinks them. It introduces some bias as it adds a new matrix within compared with the ordinary square estimator, but due to the more stable results resulting from the compared with very unstable estimates in ordinary squares under approximate multicollinearity or collinearity, even biased estimates could be more precise than unbiased estimators. The first limitation we address is that there is no an agreed criterion for the choice of the parameter lambda. This is a sort of arbitrariness arising in the model. There are some approaches based on the ridge trace, namely on the plots for each coefficient estimate at varying values of lambda. But even in this case, this information is often analyzed qualitatively, and there is some arbitrariness in the use of, for example, in the estimation of the stability resulting from this plot. The second approach we address is entropy-based, is based on entropy. In particular, it is called the generalized maximum entropy approach. This is a semi-parametric or not parametric approach, which starts from the maximum entropy principle. I will briefly discuss in the following the model specification, but the main aspect is that it starts with the maximum entropy principle, which is well known in statistical physics and in information theory. It has a sort of Bayesian flavor, since both the parameters and the error terms in the model are considered as expected values based on a given support, and with a probability distribution for each parameter and for each error term, which are found by optimization, namely by minimizing the cross entropy function, or if there are no, or in the generalized maximum entropy approach, by maximizing the entropy. It is, as I said, a very flexible approach. It can deal with multicollinearity, but also with small data sets. It does not require any distributional assumption, but even in this case, there is some arbitrariness, namely in the choice of the supports for defining both the parameters and the error terms. Our proposal is to integrate these two approaches to mitigate the sources of uncertainty in both of them, namely to use GME, generalized maximum entropy, using the supports that are defined via the ridge trace. There are a number of advantages in this approach, namely we do not consider a point estimate or a point objective function for the optimal lambda and ridge regression, but we consider intervals which are used to define to bound the model parameters and hence to bound define the supports that are used for generalized maximum entropy. It is a fully data-driven approach, which extends some previous work of collaborators by Pedro Macedo and colleagues regarding the combination of ridge regression and GME estimation. As I said, both this approach, starting from GME inference, this approach is very flexible. It does not require distributional assumptions and allows specifying quantitative criteria for model selection and specification that can be used also for comparative analysis. The main steps are the following. First, we define the supports starting from the ridge trace. Namely, we first conduct we first define the domain of the parameters. In particular, we choose generally the parameter lambda in ridge regression is assumed to lie in the 0-1 interval. We can include a very small regularization parameter to avoid in some sense, the very low or even zero case for lambda, which would return the ordinary least square estimates, which, however, are problematic under collinearity. There are other specifications which can include prior information. For example, we can choose a subinterval within the epsilon 1 interval. But in practice, in our computational approach, we can also discretize this interval, namely choosing a given number of points which define an equally spaced grid within the epsilon 1 interval. After fixing the potential values of lambda, we can find the ridge estimates of both parameters. For example, we can find the maximum value of the parameter and the minimum value of the parameter at varying lambda in our domain. And these two values, which are defined in this way, are used to specify the support for the subsequent steps, which will involve the generalized maximum entropy estimation and inference. We formalized the two different specifications, namely the asymmetric support. We choose exactly these two values, which are obtained from the ridge regression, from ridge estimates for each parameter, to define equally spaced points and a support defined by equally spaced points while fixing the number of points in the support for each parameter, which is equal to k. But we can also define a symmetric support, symmetric around 0. This is an often used approach in application, which is very interpretable, but do not fully use the bounds which are found through ridge regression. But I'm just going on, but then I can give more details if required. Even the error terms are needed, the support for error terms are needed in GME estimation. And even in this case, we specify two different approaches. The first one is based on a very well-known condition in the GME estimation literature, which is based on the 3 sigma rule. Namely, we take the plus or minus 3 times the standard deviation of the response variable and split this interval into a given number of points for J, for each observation, for each of the observation running from 1 to n. Another approach we defined is the residual-based approach. Namely, we can evaluate the residuals arising from ridge regression at different values of lambda, for lambda in our domain, find the maximum of our residuals and in absolute value, and then use this maximum as a bound to define symmetric support terms for the symmetric supports for each error terms. We can specify this maximum both observation-wise, that is for each of the n observations, but a more simpler approach is to define an overall maximum, namely to find the maximum of the residua for all n and for all lambda, and use this bound to define the supports for the error terms. Finally, we have the last 2 steps for the GME estimation that are the maximization, the constraint maximization of the entropy associated with both the probabilities for the parameters and for the error terms, subject to some constraints. Clearly, each probability for each coefficient and for each observations should be normalized to 1, as they are probability distributions. And clearly, since we are assuming that our estimates are the expected values for both the parameters and the error terms, we expect that our linear model can be expressed in this way. These are called the consistency conditions, since they relate to our observation for the dependent and independent variables, where, as I said, both the parameters and the error terms are expressed as expectation values for our probability distribution. The last steps, the inference, is based on residual bootstrapping. Namely, we can estimate the responses after finding the estimates for the parameters, based on generalized maximum entropy estimation. We can find the expected or responses, which are also estimates, and find the residuals, in this case, coming from the generalized maximum entropy estimation. These residuals can be bootstrapped, and we can find, for example, 1,000 bootstrap estimate samples drawn with replacement from this set of residuals, construct new bootstrapped observed variables, and conduct the estimates to find a distribution for all the quantities we are interested in, specifically for the distribution of the bootstrap distribution for each parameter. And from this, we can calculate everything, specifically empirical distribution. From the empirical distribution, we can calculate the confidence interval at two-side confidence interval at 95% level. As I said, we experimented based on empirical data, which are the well-known Portland cement model. This is a 4 variables, 4 predictors and 1 response variable approach. There are collinearity issues. We choose this data set since it shows collinearity issues, which it becomes even worse after the inclusion of the intercept. And we considered some performance metric based on cross-validation, root mean squared error, standard root mean squared error, and standard deviations to compare the different models. I go to the results. These are the estimates coming from the READ GME approach, both choosing no regularization and a small regularization in the choice of the ridge parameter, the asymmetric or symmetric supports for the errors, and the 3 sigma rule or the residual ridge criteria for the supports of the error terms. As we can see, the inclusion of even a small regularization has a significant, substantial impact on the estimates of the intercept. The most relevant aspect I'm going to conclude is the comparison between models. And we can see here are the models sorted by increasing cross-validation root mean squared error. And we can see that the ridge GME model performs better under this specification, asymmetric supports for the parameters, 3 sigma rule for the supports of the error terms, and a smaller regularization to avoid the occurrence of very small ridge parameters, performs better than the best choice of the ridge regression. In general, all the specification of our model performs are comparable or even better than the also in terms, for example, of standard deviation, are better than the ridge regression, and clearly are better than the ordinary least square, with only 2 exceptions. These are the point estimates and the two-sided 95% confidence intervals for the models. As we can see, the read GME, our approach provides more accurate in the sense that it provides narrower confidence intervals for surely for the intercept and even for most of the coefficients. These confidence interval are surely narrower, even narrower than the ridge regression confidence intervals. So I'm just going to summarize. Our approach is competitive and with the best estimation coming from ridge regression, outperforms clearly ordinary squares under collinearity. The best choice comes from asymmetric supports with a small regularization, the 3 sigma rule for the error terms, but even the other specifications are still acceptable and produce, for example, narrower confidence intervals for both ridge regression and clearly from ordinary least square. It should be noted as a concluding remarks that while this approach produce interpretable estimates and also allow to deal with the arbitrariness in both ridge regression in the choice of the choice of the coefficients, the parameter in ridge regression, and the arbitrariness in the definition of supports in generalized maximum entropy estimation, it provides also us with more information. We do not have only estimates and in this case also information regarding inference confidence interval, percentile confidence interval, but we also have the primary output of generalized maximum entropy, which is a distribution associated with parameters and errors. And this distribution can be also used to provide other measures, for example, based on statistical divergences such as Kullback-Leibler divergences, to compare different models. So we have much more information than only estimation and inference information. This model was implemented in both MATLAB and R, and there is an ongoing implementation in Python, and we are going to tune these approaches to provide them first on GitHub. After we are refining the code also to support users in choosing the criteria, the different criteria for the model specification, and allow more interpretability of the results. As a future work, we can also plan to consider a streaming version of generalized maximum entropy, which is called streaming generalized cross entropy, which was designed to deal with the streaming data. And even in this case, the definition of support integrating ridge regression and generalized maximum entropy, we hope to be beneficial. So I hope I'm in time, and I thank you for your attention and for an
So
interesting.
thank you, Mario, for your presentation. We still the questions for the end, if you don't mind, for to
Absolutely.
be in the channel. So we proceed for the other presentation, the third presentation virtually. This was presented by Flora Feira. Are you there? Yes? Okay. When you are ready, you can start. Flora? Okay. Can you hear? Can you talk? Flora?
Now you can hear me?
Yes, it's okay.
Sorry. So it's a problem of my side. Okay. Can you see my screen?
Yes, everything. When you are ready, you can start.
Okay. Thank you. Hello, everyone. I'm going to present the paper with the title Factors Influencing Trust in Human-Robot Interaction, a case study. This work explores how robot behavior affects how much we trust them, especially in collaborative settings. This research comes from the ICCSA project and was conducted at the Center of Mathematics in the University of Minho. The research calls the robots became more common in our homes and workplace, and trust becomes essential for humans to accept them as collaborators. And the trust can be affected by heroes or how robots explain themselves and even their tone, their expressions. And this study investigates those factors. The research goals was to understand which robots' behaviors, like speaking or showing emotion, influence trust. They also this study also explored whether participant demographics or personality play a role in this trust that the humans has in the robots, and this was tested using videos and a survey. The survey was composed by demographic factors, a God questionnaire about the trust-related dimensions, and some questions about personality. The participants watch short videos where the robot that we call Sawyer perform tasks and sometimes making mistakes or makes wrong actions, and the participants are questioned to answer some questions to evaluate the perceptions like intelligence and likability. The study focused on four main trust-related dimensions that are anthropomorphism, how human-like the robot seems, intimacy, likability, and perceived intelligence. Here, we can see a video that shows the robots making a task with a girl, and here the robot dropping the column. They apologize for that and provide some explanation about its behavior. So the questionnaires have 10 videos about that, and after that we make some questions to evaluate the dimensions about trust. The final data set include 88 valid participants. We have the same about in gender, the same number, 44 females and 44 males. About 42% were from tech-related fields, and third had some of robotic equipment at home. We measure user response via the Godspeed questionnaires, as already I said, and you use the other survey to analyze the personality, but do the low internal consistency we exclude from the further analysis. Data pre-processing, including translation from Portuguese to English, and quality filtering. We use R for statistical analysis, no parametric test for pair comparisons, and also the no parametrics correlation test for ordinal data and point visceral correlations for binary demographics. This allows us to analyze the hypothesis that we made regarding how social behaviors influence the trust. What we found regarding to demographics had light effect on trust perceptions. In this sample, we don't have higher correlations between demographics and the trust perceptions, except a slight trend where the men tended to give lower trust scores compared to the human. In the scenario 1, that have 3 videos to analyze, and on video the robots apologize only. In the other video, the robots justify and apologize. Was the video that I showed in the beginning, and in the end, the robot justify only. The results is that when we have highest scores, when the robot apologize and make a justification. So the scores in likability and perceived intelligence is higher. In scenario 2 that we shows 4 videos, the big result is that when we have verbal interactions, we have higher trust. In all 3 dimensions that we analyze, it's clear that when the robots explain the intention, that is the scenario 3, 2, 3, is the scores is higher about the trust. Regarding the fashion or the fashion expressions make a big difference. When we put the robot with any expression, let's see, the black screen that represents the face of the robot, the score is lower when we compare when the robot has a dynamic face and moving eyes, was rated more woman-like and more likable and more intelligent than one with a black screens. This supports the idea that expressions matters, even in machines. So, in conclusions, Human-like behavior, like apologizing, asking before acting, or showing expressions, made a big difference when we're talking about trust. And they aren't just features; they are direct impact whether people trust and accept robots as collaborators. And these results are are important to make decisions about how we make models to to allow the robot to be more intelligent in human robot interactions. As future directions, because this study has some limitations, we just use the videos as simulations, not physical robots. Also, the sample was limited, and personality assessments didn't work well. There are important considerations for future studies. So, for future research, we plan to include robot interaction in real world. Um, uh, Other a key direction will be to study how trust builds and fades over time. So, to include also longitudinal studies. And other plan is to study how trust builds or fades over time, uh, is, uh, and how robots can actively manage that, taking account the personality of the person. So I think I was fast. Thank you for your attention.
Thank you, Flora, for your work, for your presentation. We have few minutes for some questions. Someone in the audience can ask something to Flora. In the presence audience, no?
I got a question.
I cannot hear.
Please, loud.
My question is, first of all, congratulations for the project. Can you hear?
Can you hear, Flora?
A little bit, but I can hear. I can hear.
You can hear?
Yes.
Try to talk here. It's better. And presenting.
Yeah. First of all, congratulations for the presentation and project. My question is related time.
Okay.
How long this project takes?
1 year, because it's a result from a master student that I didn't say at the beginning. So we just have 8 answers, but it was all done in 1 year with the videos and the questionnaire. It was a lot of work, but we done in 1 year.
Okay, excellent. And what the challenges so far? I
To
suppose
collect
that many changes, but the main change for that
was the preparation of all the videos and questionnaires to do a good questionnaire was not the worst. The worst is to collect the data, to get participants to answer the questionnaire was the worst part, and takes more time because we have to give time to get participants that are able to answer to the questionnaire.
Okay.
Thank you.
Okay, thanks, Flora. Thanks. Only one doubt in your slides. I think it's number 6, but I think you concluded right. In the 6 or 7 about the significance, you said in bold are significant, but I think in bold these are non-significant values. Can you confirm this in the 7 or 6?
Let's see. In bold, in 6.
I think it's in 6 slides. Could you share with us?
Yes, I can share.
Only one doubt. I think you conclude right, but I think I saw the bold face.
In here?
Yes. No. In the next. No, no, no. It's there. I think it's there. What the meaning of the bold?
The both they are lower but significant correlations.
But the value involved is the correlation
Okay, yes,
or,
not
or the significant.
no is the value of the correlations. No,
Okay, okay. I perceive there are the p-values and
no,
I find.
no. Because it is a
Okay.
lower value, but they are significant.
Okay,
Thank
okay.
you.
Thank you for your presentation, Flora, again. So we proceed for the last but not the least with the Maxima. I think is Gustavo, the presenter of the next session. When you are ready, you can share with us.
Yes, I try to do.
This is very hot in this room. In the presential room, we are all ready to dehydrate, right?
Okay. Can you hear me? Can you hear me?
Yes,
And
I
see
hear
the.
you, but you are
Okay, let me
share the
see.
program of this session.
Yes. Let me see.
I'm here. What? Thank you, Francis.
Sorry. There is a problem because, okay. Okay, I think so. Okay. Can you see the screen now?
Share your
There.
presentation. Okay, it's all right now.
It's all right. Can you hear me?
Yes.
Okay. Thank you.
When
Thank
you
you.
are ready, you can start.
Okay. Thank you for the opportunity to be here today. This is a joint work with Luís Meira Machado. With this talk, we are interested not only to introduce a new method for the imputation of survival times with interval sensor data, but also to make a review of some existing approaches. So let me try to move on. Okay, survival analysis is a topic of the statistics that deals with modeling time to the event. This time maybe represent failure times, time to death, or relapse. Of course, in this context, the survival function plays an important role because it gives the probability of the event that does not happen by a certain point. One another aspect is, of course, censoring. Most studies deal with right sensory data, and common methods to handle these include Kaplan-Meier estimator to estimate survivor probabilities over time, or Cox and accelerate failure times regression models to assess the effect of covariates on the hazard ratios. In this work and following the presentation of Luís Meira Machado, in which he present more profoundly some of the concepts, I tried to make a slight presentation in terms of concepts. So we focus our attention interval sensory data. In this case, the inference becomes more complex compared to the right censoring. For instance, Kaplan-Meier and traditional regression models do not work well because we don't know the exact times to the event, okay? So if you apply this approach, of course, they can lead to biased survival estimates or decrease the currency of the hazard ratios. Um, in this case, possible options to make the inference better is to use another non-parametric estimator like Turnbull, in which we use iterative algorithm or apply some modifications to the regression models. In this talk, in this work, you are interested to analyze better the imputation-based methods. In this case, we have simple approaches like the lower bound, upper bound, or the midpoint that gives given by the limits of the intervals. But another possibility is to include covariates to improve the currency of the imputation. But there is a problem when you try to apply these regression models because the input times usually fall outside of the intervals. Considering these problems, we propose the scaled linear distribution method. As the main goals, these allow to ensure that the imputations times stay within the interval and at the same time keeping the natural variation of the event times. This method also use multiple replicas. In this way, it's possible to handle better with the uncertainty. Okay, so the method that we'll propose comprise 5-step procedures. In the first one, we start by generating a random times within the range for each individual. Then um, we use a model like AFT or the machine learning model. Like in this case, we have used XGBoost to predict the survival times, which is very important, may be outside the intervals. So um, the third step, we repeat m times this process, um, and we can get a distribution of these times for each of the individuals. But as I told before, we have a problem because most cases times fall outside of the intervals. So we propose to rescale that predict times in order to fit inside the intervals and at the same time preserving the overall pattern for all the time events. Finally, as a last step, the final input time is given by the median of these scale predictions. Of course, we can also estimate uncertainty via standard error and standard deviation of the M predictions. So now we illustrate the impact of the imputation methods on the survival curves. Okay, so we made several steps to reach this moment because all the specs will be in programming, but I will just present the survival functions. Okay, from this data set, German Breast Cancer Study Group is a classical data set for illness death model. In this case, we have many covariates that we have used in the regression models to input the times. And we have two times. One, the times to the recurrence that you have used in this preliminary study, and the other to the total time. Okay, so as a result of this talk, we compare the performance of the survival curves among the imputation methods. Here we have in this first figure the Turnbull estimator given by the solid black line. And the other is the Kaplan-Meier estimated using the right sensoring. In this case, we have used the time to the recurrence. It's called rect time. As expected, the non-parameter estimator shows a more stepwise and coarser curve. In fact, it is more conservative because we have less smooth due to the nature of the interval sensoring, where the exact event time, because it's not observed, we only know that times lie within an interval. In the case of Kaplan-Meier, uh, given by the dashed black line, we can see a smooth curve, of course, because in this case we know the exact time to the events with the right sensory. And we can also observe that Kaplan-Meier also overestimates the survivals, mainly in the early times. Follow. Here we have the survival curve when using the Kaplan-Meier estimator from the midpoint imputation. Um, this try to mitigate the bias introduced by the Kaplan-Meier given by the rect time. Uh, and of course, we can see that the midpoint um, survival curves in this case is better aligned with the Turnbull. Other survival curves is given by the process when you use the machine learning model XGBoost, and as we can see, this curve is close to the midpoint into this specific data set. However, in the other situations, this approach may offer better performance when the covariates are informative. But in this case, it seems not so important. It's much better when you can have data sets in which this model can capture nonlinear patterns. But probably in this data set, distribution of the times to the recurrence within the intervals is more symmetrical, and so differences are not clear. Finally, we can we also obtained the survival curve from the regression models given by the log normal distribution. Uh, it provides good approximation to the empirical behavior captured by the midpoint. Uh, since, as you can see, is very similar the curves. So this is a preliminary study. You made this, some investigation, in particular to obtain the imputation data. But here we just want to show the difference between the different methods using the survival curve. So conclusions and future research. Interval sensory data becomes the inference more complex because event times are only known within a range. As I told, this is a preliminary study. We propose the scale linear distribution method and compare it with other classical approaches using the synthetic data. Turnbull seems to be more conservative, but midpoint XGBoost and log normal give similar survival curves, suggesting reasonable right sensoring approximations. As a future work, we intend to assess the performance of the imputation methods using simulation studies, okay, to easily compare the difference between each other. Thank you so much.
Have you finished? Thank you for your presentation, Gustavo. So some questions. We have some time for few questions if you have in the room.
Yes.
No questions. in the virtual room.
Let's find it.
So I have one question.
Yes, okay.
I'm here to make questions,
Of course.
and I want to congratulate for your works. And you use the same function, the turnable same estimator from your supervisor,
Yes,
Luis, that presented the early studies.
yes,
And in this case, you use some data from literature, right?
yes. German cancer study. It's
Why?
a famous. Okay,
Yeah, I know it's a famous, it's a
yes,
famous and usual data
because
set. Why you don't start with the simulation? You want to
because
confirm some things?
yes. Thanks. Thanks for the question. The problem is how to simulate the data. Okay.
All right.
In this case, we have the covariates. Yes, and the two times. In the case of the simulation, I'm starting to work on this, but at the same time we have other research studies.
Mhm.
In this case, to try to verify how this new method works, we start by a data set that we know from other studies. But the problem is that how to simulate the data because
The
we don't have
structure, the
the
structure.
structure of the model. That is the problem.
Yes,
So
yes, I know.
to this presentation, I need to have some results to show you. So why not to use that data set? But
Okay,
in the next month, I will start to work at this aspect because it's a very important because it's the way that you have to compare the estimators because we have just a preliminary vision
okay,
of
okay.
the impact of the survival curves.
Thank you, Gustavo, for
Thank you
your
so much.
work again. And I ask for all presenters online and in presence to take a pictures with all in the room, the presenters. And if you if you can stop the sharing the work, Gustavo, to visualize
Okay.
all,
Yes, the other.
I
Let
will
me
try
see.
to put
Okay.
all in this. How can
Okay.
I go to ask my assistant, Bilga? Could you help me? I want to put all in the. Wait, I think it's here. The view.
Okay.
Yes. Okay, and I stop share. I don't want to share.
Well,
Next.
I don't know why I don't have my picture.
Don't worry, Luis. I know you are with problems. I see Luis F. Luis Philippe. Don't worry. Jorge Cabral, if you want to present yourself, I know you are a co-presenter of one of the works with Mario and Vera present in this room. Flora, if you can put your picture in the figures, thank you. And I want to put to share.
And you would like to share?
To make the presenters, Francesca, if you don't mind here, and Vera. Vera want to be in the picture. It's in George Cabral. You don't want? I need to share entire screen. Right, share this one, two, and now we go to.
We can turn the camera.
We can turn to yes. No, I don't need to share.
No,
I don't need to share anything.
because they already see that.
I only want the camera.
Yes.
This is some difficulty techniques. This is the computer science. Computer science, very, very difficult, not statistics. Wait.
Oh, sorry. I guess I'm out. I, I can I can
Chair,
enter again.
okay.
I'm going to get to move out and
Jorge Cabral will appear. Here. Thanks to all to be present in this session, and we go to the family. Yeah. Thanks. Thank you. Thank you. See you. I live in Portugal, and in Italy is better than here. It's much hot, and we don't. We need to open the windows with much noise. It's difficult to be the session without noise. Thank you again. See you somewhere.
Thank you all.
Thank you so much.
Thank you.
Thank you.
Thank you.
okay, bye.
Bye bye.
Bye.
Thank you. Thank you.
Okay.
Now it's open.
It's just to put where in the computer. This pointer works.
I will ask because it should have something like this that it is not connected, but normally it works. I will ask if they have it.
Francesca, can you hear me? Okay, because I cannot hear you anymore. There are some problems with the audio also from other. No, at all. Try to speak because I'm connected also with the YouTube channel. I just make some tests. Try to speak because I'm connected also with the YouTube channel. Francesca, can you hear me? I don't know what's happened because I connected this session also before and it worked. And also in another session, but the previous presentation doesn't work, the audio. I just thought that they... No, at all. No, I tried in 3 devices.
Ci senti?
Ok, yes.
Sì, Francia, adesso ti sentiamo.
Sì,
Ok, perfetto.
Ok, sorry for your presentation, Francesca.
Sì, un attimo.
Ok.
Ci sentite?
Yeah.
Ok.
So, no questions, Francesca? How can you prepare the problem? Thank you, Francesca. No problem. Thank you. So we proceed for the other speaker. I think is Irina. Irina?
Yes, okay.
Can you hear us?
Me?
So please share your
Yes,
presentation.
now yes. Yeah, just a moment. Just a moment. You should be able to see and to listen. Please confirm. Also, if you are able to see the presentation move.
Yes, we see your presentation, so you can start. Thank you.
Okay. Thank you so much. So, good afternoon to everyone there, and I'm going to present this research co-authored with Professor Marco Mazzarino, titled "Port Innovation and the Railway Digitalization" is a proposal for the SIM model at Porto Trieste. So, briefly, I will share insight from this research on digital railway automation and port innovation. And as you will see, we are focused on the Porto Trieste as case studies. So the analysis is framed around to SIM model is a spatial institutional innovation model that will consider the integration of 4 dimensions: territorial, embeddedness, institutional architecture, innovation ecosystem, and then circularity sustainability, as you will see later in the next slides. So these findings is important to say that are a part of Horizon Project AutoSup, means autonomous supply chain, multimodal autonomous supply chain, and draw on both qualitative and quantitative evidence that we are collected within the project. So starting from the background, so objectives of this research, we know that ports today are no longer just physical infrastructures for moving goods, but also strategic urban regional platform where territorial policy, institutional coordination, and also other facts as technological innovation and environmental sustainability may converge. This is the main step to create the SIM framework, which analyzes how different type of innovation, So spatial, governance, technological, and cognitive can interact in smart port development. So, of course, there are some challenges in the port sector. So why is innovation so urgent? So first of all, the aging of rail infrastructure, institutional fragmentation, and also the environmental stress in port territories. So with this matter of fact, the study is guided by two main research questions, as you can see there in this slide. The first of all is focus on technological innovation in railway and port system, and analyze the interconnection with the urban territorial scale. And the second research question is based on the analysis for integrated planning of freight flows and logistic automation as predictive maintenance with the transformation also of the territory. So going just the project, AutoSAP project in a nutshell. So what is an horizon that follows a human-in-the-loop approach. So empowering stakeholders to integrate technological advances in processes, and also to improve equitable transition to autonomous supply chain. There are 5 main objectives, as you can see in this, as you can see listed. And first of all is the definition of seamless multimodal automatic freight transport, the improvement of stakeholders, the creation of DSS, that means the decision support system for the port areas, also the flight flows around the port of Trieste. The design of new operational governance, organization change, management models, and also then, as you can imagine, the validation, cost efficiency of solutions, and then, but not least, the establishment of a strategic and cohesive alliance to create some roadmaps across rail, road, aviation, waterborne, and other modes of transport. So there are some evidence in this field, in particular the increase of studies on smart ports, on innovation ecosystem, and also the logistic automation. What are the main gaps? The lack of focus on rail port interface, the weak integration between digital innovation and spatial institutional governance, and then sustainability indicators not fully embedded in digital transition strategies. So considering this, one of the main focus on this step within the project and of this research is to consider the starting point of predictive maintenance to create a strong interconnection with the territory around the Port of Trieste. What is the predictive maintenance? Is a real-time diagnostic that based on sensor data, AI analytics that can monitor the condition of freight wagons and the rail infrastructures. So there are, of course, some advantages. So reducing unplanned downtime, ensure higher safety standards for rail operation, improves cost efficiency, and also contribute to environmental sustainability. How? Minimizing material waste, energy consumption, and emissions linked to system inefficiency. In the context of the Port of Trieste, the predictive maintenance will support a broader modal shift strategy, and also to the performance goals as the downtime, we can also be more aligned with the EU decarbonization goals. So starting from this state of art, the paper offer a first discussion to connect the predictive maintenance, the EU decarbonization goals, and also the institutional stakeholders part within a whole framework that calls spatial institutional innovation model that is based on 4 dimensions. And also this model applied to Trieste aim to integrate, of course, some governance innovation, but also to see predictive maintenance that nowadays also in the studies, in the pilot case studies across the Europe, is just see as a tool to improve the performance of railway operators. But in this case, we aim also to focus as a territorial innovation. So yes, let's start just briefly understand the context. We know that Trieste is a strategic port area of the Baltic Adriatic TEN-T corridor, and also the last year the port handled over 9 million tons of cargo, and it's going directly to the SIM model in practice. Let's begin with the first the first point, territorial embeddedness. The location of Porto Trieste is not only geographic but also economic and logistics. So this position inside the project is can support the Porto Trieste to include cross-border institutional coordination, especially with other countries as Austria, Slovenia, and also Hungary. According to the second dimension, institutional architecture, is institutional innovation. So mainly Trieste can demonstrate that it can become a multi-level collaborative governance developed through the AutoSAP project. And the third dimension is the component of innovation ecosystem. So through the project, the port has introduced predictive maintenance, as I said before, also digital twins and IoT for the rail terminal automation. What emerged is that is important to state, to highlight that is a cognitive infrastructures where digital tools can be integrated in training and operational processes. For training, we manage process to empower the stakeholders alliance. Then the last is circularity and sustainability. So the final model also address the environmental circular economy strategies. In the case of Porto Trieste, the circularity is based on reuse, refurbishing the rail components of the wagons, adopting materials to reduce emissions. So going to the conclusion, this is the slide of results to imagine a systemic impact of the model to create the Port of Trieste. This is a main of analysis based on 3 interconnected levels to observing transformation, also to show how innovation unfolds in complex port environments. So briefly, the first level, we start with the structural vulnerabilities. We know that we have some barriers and such as environmental pressures, air pollution, and also land use conflicts. This is relevant to highlight because it never emerged from the project, but since the project AutoSAP is a wide, broader project in the European context, there are also some land use conflicts to consider that can complicate the adoption of the digital tools into territorial innovation. At the second level, we observe targeted technological and also organizational responses. What's crucial here is to see that these solutions, the digital ones, are integrated and they can align with the institutional learning and also territorial goals. And the emergence of systemic impacts. So this innovation, after the institutionalization, produce tangible benefits that are not only the reduction of downtime, as I said before, but also to the strength, the role of the Porto Trieste at the regional and the European scale. So the port can become a model to be a smart port, resilient and reliable, as one of the main competitor ports in this case study. That is Barcelona, because it's the only one that is applied in the smart ports and digital ports. So Trieste, after Barcelona, can gain attractiveness for investment and trade. Lastly, what tell us this first analysis of research? That innovation in ports must be understood as a multi-level process and enabled by institutions shaped by strategic choices. Moreover, Trieste shows that confronting vulnerabilities head-on and coordinating across levels, the port can become efficient, sustainable, resilient, and future-oriented. Also, considering the main goals of the AutoSAP project. So going to the conclusion, as you can see here, there are some lessons from Trieste. And briefly, as I said, the port illustrates that innovation at the rail port interface is not only technological, but also institutional and learning-based process. So this first part to propose the same model mainly help us within the project and also future research to understand the complexity, to see the port from another point of view. And this is just one part of the project. We aim to reinforce the same model also with other results from the project, and also in particular as the third point, with more quantitative impact in the indicators that we are collected, and we aim to finish this data collection and indicators collection by September, so during this summer. I think, yes, I finished, and thank you so much for your time. Sorry, but okay. Sorry, but it doesn't work the camera because I have.
Thank you, Irina, for your presentation. So, any questions and remarks to this work in audience? No? No.
May just can add just one thing, that this research, of course, is ongoing because it is related to the project. The project will celebrate 1 year the next September, so must be considered also a preliminary result, a preliminary approach to study the Porto Trieste. I hope also to refine this model by the next year with the next results obtained within the project.
Okay, thank you, Irina. Now we can. Now, can we pass the word?
Technical assistant. So we proceed for the presentations of smart session, and with the work from Andrea Gallo and Federica Itano. I think it's Federica.
Yeah,
the presenter. So when you are ready, you can start, and let's go. Okay.
Sure. Let me share the screen.
Yes.
Let me know if you see it.
Yeah, yes. We can see it. Perfect. Okay. You can start.
Thank you. Okay, so good afternoon, everyone. My name is Federica Pisano. I'm currently interning at the UN Environment Program, and today I will present the article written with my colleague Andrea Gallo titled Review of Climate Change Resilience Measures in the Port Context. So ports can be described as one of the least sustainable places in the world, especially from two perspectives. On one hand, ports contribute to climate change through the emission of greenhouse gases, deriving in particular from maritime traffic, port operations, and hinterland transport logistics. In this context, although maritime transport is considered one of the most sustainable types of transport, its consequences occur especially at port level, and given the location of ports usually close to urban areas, they pose a significant threat to human and animal communities living nearby. Additionally, other impacts include soil and water pollution, toxic waste, dredging, as well as problems related to noise, light, traffic, security issues, and land use conflicts. On the other hand, ports are also starting to be seriously affected by climate change hazards. Being located in coastal areas, they are particularly exposed to sea level rise, floods, storms, winds and waves, extreme temperatures and precipitation variability, land erosion, and ocean acidification. This results in the damages of infrastructure and port equipment, poor visibility, ship decreased maneuverability, and accidents, ultimately leading to operational disruptions and delays across global supply chains with extensive economic losses. This paper, therefore, argues for a holistic study of the variety of measures aimed at implementing climate change resilience in ports, arguing for their importance given the role of ports as direct stakeholders of climate change, both as contributors and as victims. The conceptual framework that we identified creates 5 macro categories of intervention: adaptation, mitigation, soft measures, nature-based solutions, and the role of digitalization. Additionally, it is further articulated, particularly with regard to mitigation, into fuel switch, electrification, wind and solar energy, carbon capture, utilization and storage systems, and modal shift. These strategies together enhance environmental resilience in a comprehensive way, acting on the reduction of ports' negative externalities, on the enhancement of port climate resilience, and on the protection of the natural environment. Climate change resilience in ports means first and foremost adaptation, which refers to passive measures aimed at the reduction of climate change vulnerabilities through their prevention. In ports, it translates mainly into infrastructure resilience to prevent and mitigate hydrogeological risk. Here, the most widespread initiatives refer to the flood-proofing of infrastructure, such as through stormwater drainage systems, construction of dikes and breakwater walls, and the elevation of docks, terminals, and roads. Finally, in the worst-case scenario, they can also involve the retreat from high-risk areas of buildings, services, or eventually the whole port. As opposed to adaptation, mitigation acts instead on the causes of climate change, aiming to mitigate the effects, the greenhouse effect, through energy transition. It, in fact, represents the only long-term solution to combat climate change. In ports, mitigation translates into the decarbonization of logistics, infrastructure, and services that can be reached through the following measures. Firstly, the transition from fossil fuels to low or zero carbon energy sources, and among these ones we identify especially liquefied natural gas, hydrogen, ammonia, and biofuels, which, even if still limited technologies, can eventually lead to a significant oil demand decrease. Secondly, widespread electrification in ports through the replacement of vehicles, cargo equipment, and to some extent vessels with fully electric or hybrid solutions can also play an important role. Here, the experimentation of batteries for naval engines is still under experimentation. However, some vessels, some electric vessels, already exist around the world. Additionally, electrification in ports refer also to the development of the cold ironing technology, which is instead a mature and available technology around the world in numerous ports that allows for the reduction of emissions, the improvement of air quality, and the unmitigated noise. Thirdly, among renewable energy, wind and solar energy are among the most widespread energy sources produced within ports. They are used to power buildings, equipment, and vehicles, and are projected to become one of the fastest growing renewable energy markets. Moreover, systems of carbon capture, utilization, and storage can allow for a temporary or permanent reduction of CO2 emissions deriving from heavy industrial activity and energy generation in ports. Despite representing only a temporary solution, they are expected to play an important role, especially with regard to hydrogen production. Finally, modal shifts can also play a major role in the decarbonization process in ports, either from road to rail transport and from rail to inland waterways, pipelines, and short sea shipping. Apart from adaptation and mitigation, other complementary measures can help reduce negative port externalities, the so-called soft measures. These measures are short-term, non-structural, low-cost and interventions that complement hard infrastructure and technological solutions. In ports, they refer mainly to incentives such as lower port dues or rewards for ships' speed reduction or their environmental performance, but they can also refer to the provision of services such as training programs to raise awareness on sustainability, old vehicles, retirement programs, treatment for ships to reduce their friction, as well as waste management, circular economy measures, and noise pollution reduction. Similarly, nature-based solutions refer to multifunctional measures categorized in between adaptation and mitigation, and they refer to measures provided by nature itself that aim to protect, restore, and manage ecosystems. In ports, they are mainly related to the restoration of coastal areas, and such as through the creation of natural dunes, beach nourishment, the restoration of wetlands, and rainwater capture. Finally, digitalization can also be considered a sustainable element in ports' sustainability development. Smart ports, in fact, are ports that prioritize digital innovation in the context of automation, sustainable development, and the sharing of information. This translates into forecasting and warning systems, traffic and logistic chain optimization, terminal automation, for community systems, drones, and digital twins. They allow for a more effective operations and errors and risk reduction, ultimately demonstrating how ports can be considered, apart from only logistic and energy hubs, also as information and data hubs. So an excellent example of a committed port in terms of a holistic climate change resilience approach is the Port of Rotterdam. This Northern Range port is the largest container port in Europe, with over 50 million TEUs handled per year, and represents a significant economic actor of the European Union. In terms of sustainability development, the Port of Rotterdam is considered the greenest port in the world. It, in fact, aims to reduce CO2 emissions by 55% by 2030 and to become climate neutral by 2050. In terms of adaptation, despite being one of the most vulnerable ports in the world to flooding, it is nevertheless considered the safest in the world. In fact, its unique flood risk management system includes numerous measures such as the elevation of port areas, storm surge barriers, dike zones, wet proofing of buildings, as well as crisis management plans. In this context, it is worth mentioning the Iceland barrier, which is the largest moving flood barrier in the world that allows for the protection of the hinterland and the port area. Moreover, in terms of mitigation, the following measures are relevant in this port. Its commitment to carbon capture, transport and storage systems, such as the ones in the North Sea and in the Rhine, the new hydrogen pipeline and factory that makes the port of Rotterdam an international energy hub for hydrogen, its shore power strategy, according to which by 2030, 90% of vessels and cruises and 50% of container ships will have to be plugged to onshore power supply. The construction of the world's first hydrogen-powered container vessels for inland shipping, and the Rotterdam-Singapore Green Corridor. In terms of soft measures, the Port of Rotterdam is committed especially to the enhancement of security, to the reduction of air pollution and noise pollution, as well as to the provision of different green awards for clean ships. As regards instead nature-based solutions, it is especially acting in the increase of biodiversity, national parks, and the restoration of water ecosystems and animal species. And lastly, as concerns digitalization, noteworthy are its container route planning platform and the automated green energy trading platform. So in conclusion, despite the premature and pioneering concept of port sustainability development, the number of ports that choose to prioritize climate resilience around the world is increasing, prompting for the experimentation of different technologies in different fields. However, what can be noted is that the majority of them prioritize only a few of the strategies that we saw in this presentation, usually limited to mitigation one, given to their immediate benefits as regards emission reductions and air quality improvement, and to a lesser extent adaptation strategies, however, usually confined where climate change consequences have already become a threat. So this article, therefore, addresses the disproportion that exists between port sustainability priorities, arguing for the importance of implementing a holistic approach to climate resilience in ports. In fact, as demonstrated by the excellent example of the Port of Rotterdam, other measures, even if to a lesser extent, can be considered in this process and can be have an important impact. As regards both the three dimensions that we saw, such as the enhancement of port resilience, the reduction of negative externalities, and the protection of the environment. Finally, in this context, the endorsement of climate resilience by ports can also increase the economic and geopolitical competitivity, especially of minor and less competitive ports. Thank you for your attention, and if you have any questions, I'll be happy to answer them.
Thank you, Penny. For your presentation, here, and before some questions. Any questions?
From Mom too, there are questions.
Yes. No. So we can finish this session. So see you around. And can we take a picture of all participants in the session? Almost. And your online. Irina is not, yes, is there.
Yeah.
And, Francesca can.
Yeah. Come here.
Yeah. much.
This is what?
8,000 is a third.